Good day, everyone. This is Group 6 from HTL, and this is our design of experiment, which is a back valid. Our objectives is as follows. It should have a secure user code input, it should have an attempt counter, and it should have a lockout mechanism if there are too many failed attempts.
For our truth table, we only have three states. For the first state is when it's open, second state when it's not open, but also not on lockout, and for the third state is on lockout. So in order to get the open state, you have to enter the password 000 within the first three attempts. Okay, then if you got the first two attempts wrong, uh, the first two attempts wrong, it will not go into open. The vault will not open, but also it will not lock you out. But if your third attempt was wrong, then that means the it will lock you out. Then after that, I do note that the 000 can be replaced to the user's liking, so the password can be replaced. For our state transition diagram, the user starts at 0, which is the idle state, and when he inputs the password 000 correct, then it will go to S1, which is open, and it will go back to S0, which is idle. Then the next path will be if he or she inputs the wrong password. So it will go to S2, which is the wrong attempt, and then it will stay there until either first the user correctly guesses the password, then it will go to S1, then back to S0. Next, if the user gets a wrong password again, so it will stay into S2 until he gets three attempts wrong, where on the third wrong attempt, it will jump into S3, state 3, which means lockout, and the user will be stuck there or looped on that state. Our system starts when the user inputs their password. So when the user inputs their password, the system checks if this password is correct or not. If the password is correct, then it will open the vault then end the system. But if the password is not correct, then it will check if the user is at their third wrong attempt. If it's not their third wrong attempt, it will go back to insert password, then it will check again if the new password is correct or not. But if it is their third wrong attempt, then the system would lock them out until they quit the system.
Now the logism circuit. In this logism circuit, we could see here on the left side is a representation of how 6 bits of data will enter our program. Once the 6 bits of program enters the program, it will then be outputted into one output. The 6 bits will turn into one output, which will be considered as the code that the user entered. Once that code is entered, it will then enter again be placed again through 6 bits that will enter our encoder. In our encoder, from 6 bits, it will be turned into 4 bits, which can be recognized by the program as the address of each 6-bit data. Once this enters the data, it will enter then to our multiplexer. After it changed into 4 bits of data, the multiplexer is able to understand these 4 bits of data. Then it enters a decision where it is able to output either vault lock or vault open. Again, the six bits of data is turned into four, which is much more recognizable by the program, and then outputted into two, which we have two options, which is vault open or vault close. Now let's move on to the data path module. In the data path module, we have here consisting of our registers as well as our different wires, which is the main goal of this module is to actually be able to determine whether the vault will open or close. In this code, it is able to identify that there are consecutive zeros or consecutive failed attempts that will equal to closing the vault door. In this program, it is able to count how many attempts have happened. If the attempts or wrong attempts have exceeded two times, On the third attempt that it will be wrong, it will then force the vault to be locked. And once the vault is locked, it can never be opened again, regardless of the attempts. At the same time, it is also able to realize that the code is right, or when the binary input is the same as the password or the correct input within the program, it will allow the vault to be open. This data path module is also connected to our control path. This is our control path, which is responsible for signal check code. Now, signal check code is actually responsible if we want to check if the data exists within the multiplexer in the data path. If control signal check code is equals to 1, then we will continue to check within the data path module what is the value of our if the value of our input is actually equals to the correct code which will open the vault, or if that value is actually consecutively wrong, which will actually close the vault. Again, our values are represented as 1 if the vault is open and 0 if not, and 1 if the vault lockout is actually on. Now we will move on to our MUX. As we can see, also connected with our control path, with MUX select has MUX plus 1, which is able to allow us to choose between the two options. And lastly, in our MUX selector, we have here code 0, code 1, and code 2. It is actually this hard-coded memory within our program, which is able to understand that for code 0, 00001, for code 1, 0010010, and for code 2, 0011100. All of these three codes are actually considered the right code, or these are the codes that if entered by the user will actually open the vault. It's actually hard coded within the memory, allowing the MUX to understand, or our multiplexer to understand, that these are the three codes that exist within our program that will actually allow our vault to open. As well as we can see here that there's a default where if these three are not considered, we also have the option of having MUX output 000. But again, the code is able to understand that within the code, there is the right three inputs that will only allow the vault to open. And regardless, and if any other value is entered within this, regardless, it will say that the vault is actually not open. And again, three consecutive vault uh, signals that are do not open or failed attempts will cause a lockout.
This is the bank vault system module. This module is a finite state machine or control system that manages access to a bank vault based on an input code. It uses a combination of data processing and control logic to handle the input, check for validity, manage access attempts, and potentially lock out users after a certain number of failed attempts. The use of a multiplexer suggests that there are multiple pathways or conditions being managed within the system. And as you can see in the code, we have just compiled in this one big module the previous modules, which are the data path module, the control path, and the MUX selector. This is the encoder module. So this encoder module translates the 6-bit code into a 4-bit. This is the test bench module. It simulates the bank vault system and encoder modules by generating a clock signal, initializing inputs and controlling the simulation flow, running a series of test cases to verify the functionality of the vault system, particularly focusing on the handling of input codes and checking attempts. And lastly, monitoring and displaying the state of the system at each step to analyze the results of the test cases. And as you can see in the code, um, it has a clock input signal, so and there will be the input codes there. And at the last one, wherein there's like a monitor there, that is the format for the output, which will be shown in the next slide. By running the program, this will be the output of our DOE. So there will be two cases of outputs here. The first one is if the code is incorrectly placed 3 times. So as you can see in the output below, if the input code has been incorrectly inputted, the system will lock out. As you can see there, the lockout has a 1 on the third attempt because the last or the third attempt is wrong. The second one is the output if the code is correct on the first attempt. So as you can see, the input code actually is 000001 and the vault opened. And then after that, it really doesn't matter on the succeeding input code attempts because the vault is already opened. In conclusion, our project successfully demonstrates a secure bank vault system that prioritizes user security through several key mechanisms. It ensures secure user code input by validating each attempt, minimizing risks associated with unauthorized access. The user project also features an attempt counter, tracking the number of user attempts and providing essential data on access behavior. Additionally, a lockout mechanism is implemented, which activates after a specified number of failed attempts, effectively preventing further access and safeguarding sensitive information from brute force attacks. Overall, these combined features create a secure environment, embodying the essential principles of access control and user authentication for high security applications like a bank vault. Thank you for watching our presentation.